This is a video on the various animal gaits, particularly those found typically in mammals. In this video, I'm going to focus on several topics with respect to gaits and the relationship between animal body form, anatomy and morphology, and how this determines their gaits. We will look at the definition of a gait, why do animals change their gaits, what kinds of locomotion there are, bipedal and quadrupedal animals, three primary quadrupedal stances, how does the quadruped animal's body work to provide propulsion, support and balance, locomotion of the individual limb, speed of locomotion, types of gaits, for example walk, amble, trot, pace, or canter or gallop, and the conclusion. What is an animal gait? An animal gait is the repetitive pattern or sequence of limb movements used by the animal during locomotion. Individual gait patterns may vary between different species, with gaits generally not being exclusive or specific to a species. Most species will have more than one characteristic gait, and the expression of the specific gait is determined by a number of factors. A predator like a leopard, for example, will have a walking gait with different speeds, slow, medium and fast, a trotting gait and a full gallop. Why do animals change their gaits? Animals vary their gaits for a number of reasons, but all are linked to efficiency of movement and therefore conservation of energy based on the circumstances the animal finds itself in. Factors requiring a change in gait include terrain changes, pursuit of prey, escape from predators, foraging, patrolling territory, crossing obstacles, change in mood, change in condition or exhaustion, injury, advertising during courtship, stalking, concealment posture, play, alarm or evasive action, and charging a threat. What kinds of locomotion are there? Animals can move in a number of different ways, and their locomotion or movement is determined by their habitat type or terrain, body form, and ecological needs. Types of locomotion include flying, which is typical of birds, which flap their wings for flight. Gliding and soaring, which is typical of creatures like flying fish, various flying squirrels, gliding frogs, flying snakes, and a number of soaring birds, which use thermals. Jet propulsion is typical of cephalopods, which use their funnel to expel water and therefore provide a jet propulsion. Contractions or undulations, this is typical for jellyfish and nudibranchs, which will move by contractions or undulations. Floating or drifting, this is a form of passive locomotion, typical of the Portuguese man of war, which is a hydroid, Porpita and Velella, Glaucus atlantica, and certain jellyfish. Swimming, from side to side caudal propulsion, is typical of all fish, including all the sharks. Swimming with up and down caudal propulsion, this is typical of dolphins, manatees and dugongs, which all move with an upward and downward propulsion of their fins. Swimming by paddling with fins or flippers, a mola, for example, or sunfish swims by using its dorsal and anal fin as flippers and also or paddles, and also penguins swim by means of their modified wings, which form flippers. Swimming with a sinuous or eel-like movement is typical of all the eels, and of course sea snakes and terrestrial snakes when they find themselves in a water medium. Inching is typical of worms and caterpillars, for example the inchworm, which is a caterpillar species. Crawling or creeping, this is typical of creatures like millipedes, which use their peristaltic contractions of their many legs to move forward, and the crawling is also, or creeping is also typical of undersea creatures like octopus, which move underwater along the seabed by crawling or creeping. Sinuous movements, this is typical of snakes and creatures like the centipede. Sidewinding, sidewinding is typical of desert snakes that have to move like that to avoid excessive contact with the hot sand. and would be typical of horned adders and similar species. Leaping, hopping, and bounding. This is typical of kangaroos, Cape spring hares, pictured here, and many other creatures. Bipedal movement, typical of primates, particularly the apes and lesser apes. Quadrupedal movement, typical of most mammal species, which move on all fours. And brachiating, which is typical of primates that swing by their arms. Here we have a log gibbon pictured, which is an animal that typically expresses that kind of locomotion form or brachiation. Bipedal and quadrupedal animals. Our primary focus is on terrestrial mammals that are defined as bipedal or quadrupedal. Bipedal animals, these animals walk in an upright fashion and use only two limbs to move. Their primary gaits are walking, running, skipping, and hopping. Their pattern of movement is either alternation of limbs with a left-right pattern with successive limbs providing the propulsion, support, and balance, or they move by hopping using both limbs to propel them forward simultaneously to support the body as it lands and absorb impact and to balance the animal. Bipedal hopping gait animals include kangaroos, wallabies, Cape spring hares, jerboas, and many passerine birds which feed on the ground. Their primary gaits are walking, running, skipping, and hopping. Bipedal animals that move by walking or striding or running with alternate movement of the limbs include most birds, and is well illustrated in the ratites such as ostriches, emus, and cassowaries. Even some lizards are able to run in this fashion. For example, the basilisk lizard of the Americas can run bipedally over water, hence their nickname, the Jesus lizard. When bipedal animals skip, they are not running, but are hopping using alternate legs for support and propulsion. Most land mammals, particularly the vertebrates, move on all fours, and animal gaits in this context will be discussed with this in mind. The primary gaits for quadrupeds are described as a walk or amble, a trot, a pace or rack, a canter, and a gallop. Quadrupeds have three primary stances based on their foot anatomy: plantigrade, digitigrade, and unguligrade. Plantigrade animals are flat-footed animals. The bones of the hand or foot are placed flat on the ground. Digitigrade animals, the first digit is reduced or lost. Bones of the hand and foot are elevated. Unguligrade animals have a reduced number of digits, for example horses, antelope, and rhinoceros. They walk on the tips of their remaining digits, and their claws have become modified to form hooves. In this slide you can see several track patterns of different kinds of animals. Porcupines, which are plantigrade, jackals, which are digitigrade, bipedal bird tracks, which are also considered digitigrade, and the semi-digitigrade tracks of an elephant walking away. Plantigrade animals. These terrestrial animals walk with their toes and metatarsals placed flat on the ground. They therefore walk on the soles of their feet. Examples include humans, badgers, bears, raccoons, skunks, wolverines, red pandas, rodents, lagomorphs such as rabbits and hares, hedgehogs, hyraxes, and kangaroos. On the bottom right you can see the track, hand and footprint of a baboon, a chacma baboon. Digitigrade animals. These animals walk on their digits or toes, or generally their distal and intermediate phalanges, which are their fingers or toes. Usually more than one segment of their digits touches the ground during locomotion. Examples include walking birds, felids and canids, hyenids, elephants, which are semi-digitigrade, capybaras, hippopotamus, and pigs, which are all semi-digitigrade. Unguligrade animals. These animals walk on the most distal tips of their digits and never engage more than a single joint of each digit. Examples include all even-toed and odd-toed hoofed animals, with the exception of pigs and hippos, which are considered semi-digitigrade. How does the quadruped's animal's body work to provide propulsion, support, and balance? Quadrupeds are designed with one or two two primary body types based on their diet. Ungulates are primarily herbivores. They have a relatively large, heavy, and inflexible trunk to accommodate the large stomach and intestine needed to digest their vegetable diet. Their limbs are designed specifically for running at high speeds and are characterized or rely specifically on their limb elongation for running. Plantigrades, such as monkeys, baboons, bears, and badgers, are all omnivores, and to a greater degree, digitigrades, mostly felids, canids, and hyenids, are carnivores, and they tend to generally have a smaller or sleeker trunk since they do not need to have a large gut for digestion of their meat diet, which is a low volume or less bulky diet, yet high energy. They therefore have a characteristically more flexible trunk which assists with the running process. This allows for their limbs to function not only in locomotion at high speeds, but also for secondary function of manipulation related to their diet and their need to subdue their prey. These realities define the locomotion of these animals based on the evolutionary development of locomotion as it relates to their diet. Adaptations for quadruped locomotion. Quadrupeds that can run their prey down are defined as cursorial predators, for example, wolves and hyena. Their body's design necessitates that their hind or pelvic limbs are used for propulsion. The thoracic or pectoral limbs function in the support, stabilization, and balance of the animal. The tail functions in balance by helping to shift the center of gravity to counter the momentum of the gravity shift as the animal moves. Generally, the center of gravity is located in the trunk just behind the forelimbs. As the animal moves, the center of gravity shifts back and forth in a longitudinal direction and laterally in a side-to-side direction. The extent to which this shift in gravity occurs and the direction of movement, lateral or longitudinal, that this occurs in is determined by the speed of locomotion and therefore the gait. When an animal is moving slowly or walking, its momentum shifts laterally so that the animal's body sways from side to side and the tail is left to compensate for this by moving from side to side. The limbs respond by spreading to stabilize and counteract the side to side inertia of the body as its center of gravity shifts. As the animal accelerates, the momentum shifts the center of gravity in a longitudinal rather than in a lateral direction. The forward thrust is therefore provided by hind or pelvic limbs, which are powerful and long to accelerate the animal. The hind limbs also provide upward thrust to counteract the force of gravity. The animal spends less time contacting the ground with the limbs at high speed, and the feet touch the ground toward the center of the animal's weight distribution to maintain balance. The front limbs support the animal's weight as it is thrust forward and provide upward propulsion to counteract gravity as they stabilize and balance the animal. This helps to continue the direction of momentum in a forward direction. A shift in body attitude or position shifts the center of gravity forward or back, engaging the forelimbs more or less depending on whether the head of the animal is raised or dropped. This affects the force of propulsion of the hind limbs and the extent to which the forelimbs contribute, if at all, to the forward momentum. The upward and downward movement of the body as the animal moves provides for some energy conservation by utilizing the elasticity of the muscles and ligaments to store potential energy, which can be explosively released as kinetic energy to provide a rebounding force countering the force of gravity. This stored kinetic energy is the reason why certain gaits at high speed are more efficient than others. Kangaroos and Cape Spring hares are examples of animals that might use this potential energy efficiently at high speed. Animals with a digitigrade or unguligrade posture are generally faster as opposed to plantigrade animals, since their foot strikes spend less time in contact with the ground and also provide a smaller surface area by which forward momentum can be lost due to friction. Locomotion of the individual limbs. No matter which gait an animal employs, it must, of necessity, use each of its limbs in the following sequence: lift, swing, support, and thrust. Lift is where the animal raises the limb off the substrate. Swing is the forward or backward swing of the limb. Support is where the limb makes contact with the substrate. And thrust is the push off from the substrate. Locomotion. The speed of locomotion and gait is determined in part by the step speed, how rapidly the limbs go through the lift, swing, support, and thrust sequence. The stride length, a longer stride produces a faster speed. Limb support time, the less time spent on the ground, the faster the animal is. Coordination of limbs relative to each other to avoid interference. And the pattern of movement of limbs, which is a sequence of limb steps relative to each other. Types of gaits. Quadrupedal locomotion includes bounding, stotting, walking, ambling, trotting, pacing, cantering, and galloping with transverse and rotatory gallops. Bipedal locomotion includes striding, walking, running or skipping, and hopping. The bipedal walk is different from the quadrupedal walk in that the track pattern involves only 2 tracks left and right instead of 4 tracks, front and back pairs left and right. Striding or walking is basically a bipedal walk that is represented by a striding pattern where the alternate feet step or stride one after the other. Bipedal locomotion continued. Running. The bipedal run has a longer stride and the tracks tend to show deep toe impressions with little or no heel impression with lots of smudging of the track. The track's straddle width also narrows at high speed. Leaping or skipping. This is where the animal is leaping from toe to toe and resembles a running stride in every way except the animal is pausing briefly with each footfall. Typically, the track impression can be expected to be better than with a running stride. This is the kind of measured, rapid stride associated with a human crossing a mud patch or a puddle. In bipedal locomotion, hopping. This is a form of bipedal locomotion where the animal leaps from both feet simultaneously and lands on both feet simultaneously. The track pattern is a set of paired tracks roughly hip wide. At higher speed, the distance between the tracks increases dramatically, with some animals, such as kangaroos, having a track pattern several meters apart. Smaller bipedal hoppers, such as jerboas and Cape Spring hare, will have correspondingly shorter distances between track sets in comparison. A tail may show behind the paired footprints depending on the speed of the gait. Usually a walking speed hop with the tail less likely to show at higher speed when the animal is usually in full flight from a predator and holds the tail up for balance. Kangaroos and Cape Spring hares will often show their forepaws in the tracks between the tracks of the hind limbs when they are moving slowly or walking. The forelimbs are often used for support, almost like a lever, as the hind limbs are brought forward for the next stride, in the same way a bounding animal would move. Stotting or pronking. This is the equivalent of a bipedal hop, but with 4 legs. The feet of each pair of legs lands simultaneously, and the track pattern is made of 2 pairs of tracks, one pair behind the other, separated by a large distance as the animal hops or stots to its next position. This form of locomotion is limited to antelope and is typical of only 2 situations. The first is when antelope are being threatened by a predator within the area of discomfort or flight zone. The antelope stots or hops to indicate its fitness and therefore persuades the predator that it cannot easily be caught and therefore should not be pursued. The second situation where a stot may be used is when an antelope, ram or bull, depending on the size of the species, is in rut and is displaying for females and other males to declare its fitness for mating and to intimidate the other males. The gait is referred to in this case as pronking. Bounding. This is a form of hopping where the animal lands on its forelegs and then brings its hind legs forward of the forelegs, as it prepares to leap forward again for its next bound. The forelegs do not land simultaneously or side by side so that the tracks are one ahead of the other in the track pattern. The hind tracks do, however, land side by side, but because the hind legs are brought forward of the front limbs, the hind tracks form a pair of tracks with each foot placed on the outside and ahead of the front tracks. The track sequence is a 3-beat pattern. The 2 front limbs strike first, one after the other, followed by the 3rd beat as both hind limbs land. The animal then leaps off its hind feet to repeat the sequence. The resultant track pattern looks like a letter L. When a rabbit or hare is moving very slowly, that is, slow walking pace, the front tracks are placed virtually right next to one another, as in the image here of snowshoe hare tracks. The same track structure might be seen in kangaroos too when they are walking. Rabbits, hares, and squirrels typically make bounding track patterns. The walking gait. The walking gait is the slowest gait. It is called a 4-beat gait. In other words, each of the legs steps sequentially with the other 3 legs. The head generally moves up and down in concert with the steps being taken by the forelimbs, dropping as the forelimb is lifted and rising as it is placed on the ground for support. Similarly, the head and tail will swing back and forth as the support moves from one side to another and up and down in response to the lifting and placing of forelimbs. Usually the hind limb is placed in the same relative position as the corresponding forelimb on the same side of the body. That's in the tracks, of course. Where this occurs directly, it is called registering and is common in all felids or cats. If an animal is distracted or startled mid-stride, the forelimb might be delayed in movement from its position, causing interference with the hind limb, which needs to be placed in the forelimb position for balance and to continue the stride. This is called an interference or side placement. When an animal walks at normal walking pace, it usually registers or partial registers. Characteristic of a normal quadrupedal walk is that the duration of the support of the limb exceeds that of its swing. Also, during a single stride, a stride being a single sequence of steps before the gait pattern repeats itself beginning with the same limb, the animal's body is supported alternately by 3 limbs 4 times and 2 limbs 4 times, producing 8 combinations of limb support. The step sequence shows clearly how the forelimbs follow one another in sequence, making a 4-beat sequence. The walking gait pattern. The track pattern goes in the following sequence. In this first image, the animal is supported by 3 limbs, 2 forelimbs and 1 hind limb. The right forelimb is lifted and the body is now supported by the fore and hind limbs on the left side. This is the limb of the same side or ipsilateral. This is the limbs of the same side or ipsilateral to one another. The left hind limb thrusts, the left forelimb supports during this phase. As the right forelimb swings forward, the right hind limb strikes the ground for the support phase, so that there is again a 3-limb support. The left hind limb is now lifted and the animal is now supported on 2 diagonally placed or contralateral limbs. Here the hind limb is now supporting and the forelimb is now thrusting. The right forelimb has now swung forward and is placed down to support the body once again in a 3-limb support posture, with the left hind limb raised off the ground and swinging forward this time. The left limb now lifts off the ground and begins to swing forward, balancing the animal on 2 ipsilateral limbs. That's on the right side this time, once again. The left hind limb now strikes the ground in support phase and the body is now supported on 3 limbs again. Finally, the stride is completed when the right hind limb is once again lifted so that the animal is supported on diagonally opposed limbs or 2 limbs. When an animal is straining up a hill or under a heavy load, it will spend very little to no time on the 2-limb phase of locomotion to compensate for the force needed to move. Walking gait speed. Quicker walking. As the speed of walking increases, the support phase decreases until it is of roughly the same duration as the swing phase of each step. Support by 3 limbs is now less likely, and so the animal moves directly from the ipsilateral 2-limb support phase to the diagonal or contralateral 2-limb support phase. Thus a sequence of lateral support followed by diagonal support and back to lateral support occurs. The hind limb now oversteps the ipsilateral forelimb in position so that the hind track appears ahead of the forelimb track on the track sequence. This quick walk may also be referred to as an amble and is used by an elephant when shuffling along in a run. The step sequence is the same in the ambling gait as with the walk, but with a 4-beat sequence, of course, where all 4 limbs follow in step sequentially. In a slow amble, the stride cycle goes from a right diagonal to a left lateral to a left diagonal and a right lateral. This is a natural gait for the elephant. A fast amble. In a fast amble, the animal moves its support from one limb to 2 limbs, alternating so that a stride cycle goes from right forelimb to a right diagonal to the left hind limb to the left lateral, then a left forelimb, a left diagonal, a right hind limb, and a right lateral. Here we have a rhino cow trotting while the calf is forced to gallop to keep up with a much larger mother's stride, the trot. With the trot is a 2-beat gait where right and left diagonals alternate in supporting the weight of the animal. It is characterized by diagonally contralateral limbs moving in unison. So a right forelimb would move in unison with the left hind limb and vice versa. Although the limbs appear to strike the ground simultaneously, the hind limb strikes the ground a little ahead of the forelimb and provides forward and vertical propulsion. The body oscillates or lifts up and down in the vertical plane, and the head and neck are fixed in an upright position. When the trot breaks into a running trot, there's a brief period or phase of suspension following each diagonal support phase. Because of the increase in the length of the stride, the animal has to avoid interference of the hind limb striking the forelimb on the same side or ipsilateral side. To avoid this, the animal must either lift the forepaw just before the hind paw arrives, or the hind paw must land to the side of the forepaw, and it must move with a crab-like gait, with the trunk at an angle to the line of progression. This is called a side trot and is common in cursorial canids such as wolves. Where animals trot slowly, they will no longer have an intermittent suspension phase and will resort to a 3-limb support phase between diagonal support phases, particularly if the support phase is prolonged and the swing phase is shortened. The longer the body of an animal, the less likely it is to have to compensate with the crab walk or other means to avoid interference of the hind foot by the front foot. It also allows the animal the luxury of extending its support phase. This gait is a favorite of canids, particularly when foraging. Pace. The flying pace is a 2-beat pace with a suspension between each support phase. This hyena is pacing, but is not doing a flying pace, since there is no suspension between support phases. The animal uses a lateral support phase, meaning that it uses its ipsilateral limbs to support the body between suspensions. So the left foreleg walks in unison with the left hind leg, with the foreleg working slightly ahead of the hind leg. With a slow pace, the support phase might increase in duration and necessitate the intervention of a diagonal support phase between the lateral support phases. The contralateral forelimb lands just before the ipsilateral limbs on the opposite side land. Because the lateral limbs strike the ground on either side of the center of gravity, the body of necessity oscillates laterally or from side to side. There is, however, far less vertical oscillation than with the trot. Typically injured, fatigued, or weak animals will resort to this gait over the trot, and it is common in foals and puppies which have weaker muscles than adults. They will eventually convert to the trot with time. The gait helps with endurance. The pace is a natural gait for camels, giraffe, hyena, elephants, and bears, also springbuck and blessbuck. Here one can see a giraffe pacing in the main image with a young calf in the GIF inset demonstrating the same gait. The canter. The canter is a 3-beat gait and is characterized by a sequence of 1 to 2 to 1, where a hind limb strikes the ground, followed by a diagonal or contralateral strike with opposing limbs, and then followed by a forelimb strike. The beats in a sequence refer to the number of times the limbs strike the ground in the sequence pattern. Where 2 limbs strike the ground at about the same time, that would be referred to as a single beat, even though there are two limbs involved. The canter will include a period of suspension at higher speeds and is referred to as a slow gallop, sustained gallop, or middle gallop. Because the gait has a leading forelimb that supports the body weight longer than the diagonal face forelimb, it is referred to as an asymmetrical gait and may be referred to as a left or right leading asymmetrical gait, depending on which side the leading forelimb is. The canter provides good support because of the distribution of weight over the two contralateral limbs and the third forelimb, and the hind limb strikes in the sequence. It is therefore ideal for traversing rough ground in a cruising or loping fashion. Here you can see the sequence of the canter showing a hind limb strike first beat, followed by a right diagonal strike second beat, then a final left forelimb strike third beat, followed by a suspension before the sequence pattern is repeated. Animals using the canter as a gait will frequently shift the leading forelimb to avoid fatigue, and where an animal turns to move in a circular path, the inside forelimb will tend to take over to compensate for the lateral drive of the outside hind leg, pushing the animal forward and inward to the center of the circle. Although slower than a trot, the canter can be shifted into a transverse gallop. The transverse gallop. The transverse gallop is a 4-beat single suspension gait. The gait is defined by the leading forelimb, which supports the weight during gallop just before suspension. The leading forelimb has a much longer stride and remains on the ground for a longer period than the non-leading forelimb. After suspension, the hind limb diagonal to the forelimb strikes the ground. The hind limbs provide the major propulsive force, and the second hind limb to strike the ground following suspension is the one that provides the most propulsive force, because the first hind limb striking after suspension is extended and therefore under more strain than the second hind limb, and therefore less able to produce or provide as much force. It is essentially catching the weight of the animal as it drops following suspension. The canter leads naturally to this transverse gallop. Splitting the diagonal of the canter turns the 3-beat gait of the canter into a 4-beat gait and therefore a transverse gait. Stride length is doubled in the transverse gait as suspension distance and the reach of the limbs is increased. The transverse gallop is the primary gallop of equines such as zebras and cattle and other large ungulates such as antelope, and is characterized by a rocking action along the length of the body. It is their fastest gallop for these animals, although it is a tiring gait for them. Although the giraffe moves at a pace or rack when moving slowly, its gait changes to a transverse gallop at high speed. The rotatory gallop. The rotatory gallop is the fastest gait for canids and is also referred to as the double suspension gallop or jumping gallop. It is a 4-beat double suspension gait. The pattern of the limb impact rotates from the right hind, left hind, extended suspension, the trunk is extended fully, left forelimb, right forelimb, collected suspension as the trunk contracts to bring the hind limbs forward for the next ground strike. The rotatory gallop is characterized by a rotatory pattern of the limb impact and the double suspension per stride. This gait is favored by carnivores as well as pigs, small ungulates, and rodents. The leading forelimb and hind limb are the primary or dominant propulsive forces and are the last limbs to leave the ground before the collected and extended suspensions respectively. Although the rotatory gallop is the fastest of all gaits, it is used by predators such as the cheetah, which is the fastest land mammal, and the pronghorn antelope, which is the second fastest land mammal. It is also the most tiring gait. The cheetah has double the stride length of a horse relative to its height and can cover 9 meters in a single stride suspension. Carnivores increase their stride and therefore their speed by flexion or compression and extension of their vertebral column or trunk during the 2-phase suspension. The compression of the trunk, called the collected phase, allows them to place their hind paws far in advance of the forepaws, while the trunk extension during hind limb propulsion enables them to extend the reach of the forepaws and therefore stride as they leap forward during this extended suspension phase of the gait. The muscles of the hamstring and back play a major role during this stride. In conclusion, animal gaits are fascinating to study And understanding animal gaits will help your tracking ability tremendously, since it will allow for better trailing or following of the animal, as well as interpretation of the mood of the animal and its activity. It can also be used to help identify unclear track sequences that have melted in the snow or that occur on poor tracking substrate. The end. Thank you for watching. I hope you enjoyed the content. Please like and subscribe to the Wilderness channel.